In this video, we'll discuss about lightning. Lightning occurs due to electric charges in the atmosphere. Lightning is hotter than the sun. Lightning is literally electricity flowing through the air. But wait a minute. Does electricity normally flow through the air? If I keep my hand near a power socket, do I get a shock? Does electricity flow through the air here? No. Then how come electricity flows through the air in the case of lightning? Let's try to understand this with exploring lightning within a single cloud. Let's say you have a cloud here. What happens to a cloud just before lightning is that charges within the cloud get separated. A lot of positive charges gather near the top, with some negative charges as well, and a lot of negative charges gather near the bottom with a few positive charges as well. Now this is called charge separation. You might be wondering why charge separation occurs. Charge separation occurs due to collisions between particles, which is like a rubbing of particles. Let me explain. Let's say you have a cloud and you have a water vapor particle somewhere there, and another water vapor particle is moving upward toward the cloud. At some point they collide, and the moment they collide they rub against each other, and one turns positive and one turns negative. The particle that was moving upward turns positive and the other particle stays negative. Well, you might be wondering, wait a minute, why should one turn positive when they collide? Remember, when you rubbed a comb against your hair, don't you think one of them turned positive and one body turned negative? Something similar is happening here. So the positively charged particle is now going to move upward, continue on its way, and get settled on the top of the cloud. Now, when we have one positive charge accumulated near the top and one negative charge accumulated near the bottom, nothing's going to happen. But when such rubbing keeps happening again and again, you end up with a large number of positive charges near the top and a large number of excess negative charges near the bottom. And when that happens, at some point, the attraction between these positive charges and these negative charges is very high. And that causes them to move towards each other, and bang, you have lightning. So the flow of charges is what causes lightning. Okay, now this is how lightning within a cloud looks like. Fascinating, isn't it? Okay, sometimes lightning happens between two clouds. How does that work? Let's say you have one cloud, again the charges have already been separated, and another cloud charges have been separated here as well. If these clouds come close to each other, what happens is that these negative charges get attracted to these positive charges, and then they suddenly start moving towards each other, and that causes lightning. This is how that looks. If you look carefully, you don't see lightning striking the ground here, but rather striking different clouds. But you might remember seeing lightning striking the ground or a building or a tree on the ground. How does that work? That kind of lightning is called cloud-to-ground lightning. This kind of lightning is also called a lightning strike. When lightning hits the ground, it's called a lightning strike. Let's see how that works. Let's say you have a cloud here with charges separated, and then here's the ground. You have a post on the ground which has both positive and negative charges. But wait a minute, there's a lot of negative charge accumulated here. Don't you think all that excess negative charge would repel all the charges, all the negative charges on the rod, and make them go away towards the ground, right? And that's because of repulsion, right? Okay, great. Now we have a lot of negative charges here, but we have a lot of positive charges here. Don't you think negative charges here would get attracted to the positive charges here and vice versa? And that attraction would cause negative charges to want to move towards the pole and positive charges from the pole to want to move towards the cloud. And when those charges meet, you have lightning. And obviously that's because of flow of charges between the cloud and the ground. Okay, now I'm sure you've heard of scenarios where lightning strikes, causes a fire and causes damage, right? And you may have wondered that when lightning struck this building, did anything happen to the people on the building? Well, nothing happened to the people on the building. This is a building in Toronto, which often sees lightning strikes, and nothing happens to people. How is that possible? Because this building and many other buildings around us are all equipped with something we call as the lightning conductor. A lightning conductor is basically a safety device that saves us from lightning. Okay, let's see how that works. So here's our building. The lightning conductor is that rod on top of the building. It's usually made of copper and it's connected to the ground through a copper wire. Below the ground, we place an iron rod. Okay, now let's see how this thing works. Let's say we have this dangerous cloud with a lot of charges which are separated. And now what do you think would happen? Don't you think the negative charges in the lightning conductor would move down? And then you'd be left with an excess of positive charges on the lightning conductor? Pause for a moment and think about that. Okay, so when that happens, we know that these negative charges love these positive charges, and these positive charges love these negative charges, and so they want to run towards each other, and so the negative charges start moving towards the lightning conductor, and the positive charges from the lightning conductor move towards the negative charges in the cloud, and bang, you have lightning. The moment this happens, charges start flowing towards the ground. And when charges flow towards this iron rod in the ground, they slowly get distributed in the ground and nothing happens to people inside the building. Now, if you look carefully at this building, you'll notice that the lightning conductor is the topmost point on this building, right? And because of that, the negative charges are going to run away from this point much faster than at any other point on the building. Why? Because the lightning conductor is closest to the negative charges in the cloud. And because of that, the lightning will strike the lightning conductor only. And because of that, people within the building will stay safe. Okay, let me show you a simple small animation of how a lightning conductor works. So here is our cloud with excess negative charge, the bottom with excess negative charge, and here is the ground with excess positive charge. Here is our building and this is the lightning conductor. When the negative charges start making their way towards the building, positive charges from the lightning conductor are going to meet it, and the moment they meet, you have lightning. You can think of that meeting like a nice little electrifying handshake between the positive and the negative charges in the lightning. Okay, all the charges now flow to the lightning conductor. They don't hit the building, and from the lightning conductor, they flow into the ground, and everyone in the building stays safe. That's it for this video. Thank you.